Let's talk about the simple model using the arena. Last time actually I introduced a simple process system having a one queue, right, at the drilling center. Drilling center that has as you know, has one drill press, and then part arrives at the drilling center according to the given labor process also, and then once it got it each process is finished, and then definitely it will leave the system. Okay, and we have only have one drill press, so in this case, and so you can also consider this one is an MMN system according to the queuing theory. Okay, and so if you have this system, and basically we can actually illustrate the process using the flow chart. So once part enter the system, and then it should check the availability of the server, as you know. So if server is idle, and then definitely it will seize the part will seize the drill and drill press, right? And however, if not, and then in other words, is already resolved by the another part, and definitely it should be in the queue, right? Parts should be sent to the queue so that it can actually wait for the next service. Good. And then when part service actually get its service, and definitely it will leave the system. Okay, so this is a flow chart to illustrate the process of this system. So when you conduct the project actually, or to write the paper using the simulation, and basically, so you have once you have the real system, you need to develop the conceptual model, including the flow chart, so that actually in that way you can actually develop the simulation model really well or easily. And also we need the input data to develop the simulation model, right? So arrival time, of course, we need to have information about the arrival time. First, the arrival time of the first part, right? And then once you know about the first arrival, then definitely you can also generate the next entity, right? According to the given interval time distribution, like exponential distribution with the mean of 5, right, minute. And service time, also we need a service time. In this problem, we have a triangular distribution with the three parameters, 1, 3, 6 minutes. Okay, so based on this input data, we are ready, actually we can develop the simulation model. Okay, so hopefully you have an Arena software. If you don't have anyone and basic anything, nothing actually in your system, and definitely you can go to the Google, and then you can type the Lagwell, uh, right, Lagwell software and Arena, and definitely you can download this Lagwell software. Yes, so you can click the download the free trial, and good thing is that Arena actually provide the free version for the student, okay, for student education. So once you type all the information, definitely it will send you the link, and then you can download the trial version or student version of Arena. Okay. So once you have Arena software, uh, once once you download the Arena software, and basically you can actually install the software. So mine was a version 16, and then if you go to this media image folder, and then definitely you can have to run a file. So if you run this, and then basically you can actually install the Arena software. Okay, so here, and then you can actually install other software as well, but you can just click the install Arena 64 byte. Okay, the third option. So once you click the button, you will get the warning message, and if you want to continue this, actually you can click yes, and then if in my case I have the previous version, it's the same version, Arena 16, and so that's why I have another warning sign. But if you just follow this procedure, actually you can install the software. So when you open the Arena software, when the Arena software, actually you can have this kind of view. And definitely this is the student version for your education. And then we have the menu over here, and then also we have project bar on the left side. Okay, and then this is a main project view, and then next one is the message window. So you can actually drag and drop the basic modules over this main window, something like this. Okay, and before we go forward, actually I just would like to introduce another model which will be discussed in this class, and model 3-1. So here is a model 3-1, and then we will develop this model in this class. Yes, so here, okay, we have three different modules, and then this one is known as a create module, and actually you can develop this one from this menu. Actually, by using this menu you can create this module and just drag and drop it over here. And anyway, so create module will actually help you generate an entity. In this case, we have a part or library, right? So this is an entity type, actually is a part. Okay, you can use any other names if you want it, but yes, let's use a part as a name of the entity. And then also you need to set the first generation of this entity. Okay, over here, let me use a magnifier for you. Okay, so it's better, right? So part, and then first generation of the part is 0. Okay, and then maximum library of the entity is infinite, right? And then the entity per library, which means whenever a library event or whenever there is a library event, and then there is only one entity will enter the system, right? Will enter the system. So that's why we put 1 here, and usually we put 1 here. However, if you just consider the bulk library or batch library, and definitely you can increase the number of entities over here per library. So usually it is 1, and usually this is infinite. Okay, and anyway, so first generation of the part is time 0. Okay, this is a simulation time, and then interlevel time between the part following the exponential distribution. So you can actually set up the type of the distribution over here, and then value is 5 minutes. So just don't forget about the time units. So this is a minute. So every 5 minutes we will have a part, but because the interlevel time actually following the exponential distribution, so maybe their interlevel time can be slightly different. Some of them actually will take 6 minutes or 7 minutes or 3 minutes and so on, because this is a random distribution. Okay, so you still remember the definition of the statistical distribution, right? So yeah, anyway, so once part library and once part is generated in Arena, actually it will be sent to the process at the drilling center, right? Drill press. So this is a process module, and if you look at this drill center, and we have this drill center use a 1 unit of the drill press, which is a resource. I already mentioned about the definition of resource, right? So this process uses this resource. Okay, resource is different from the process. Process use the resource for each service. So whenever part enter this process module, and then it will seize the drill press, 1 unit of drill press, and then spend some time. How much? Yeah, according to this delay type. So it will span the triangular distribution with the 3 parameter. Minimum value is 1, and then most likely 3 minutes, and maximum is 6 minutes. Okay, and time unit is minutes, so that's why I keep saying the minute over in here. So it will span will be the service time or processing time. Okay, and then based on this time, after this time, actually that means this is a delay, right? And then this module, process module, will allow the entity to release this drill press. Okay, so that's why action is a cease, delay, release. However, there are other actions, but I will explain the other actions in future. Okay, so I'll close this. And next one, the dispose module. So if you click it, yeah, it has just nothing. It just this module has just a name, so which is just a label. Okay. However, whenever you must have dispose module so that all the statistics associated with a certain entity can be saved. Okay, and can be recorded in Arena. Okay, automatically. So that's why you need to have a dispose module. And let me zoom out. So you also have 2 graph, and then if you want it, you can have these 2 graph in future. So basically, first figure show you the number of waiting in the queue, okay, entity in the queue, and then this is number of busy server, okay, in the queue. So this is will be actually used to calculate the utilization of your resource, right, which is drill press, right? So let me just close this one magnifier. If you run the simulation model, if you go to run setup, I already put the 20 minute as a simulation run time, which is the replication length. And anyway, so if I run the simulation model here, and definitely you can see that this kind of graph, okay, in this model. And also this was so quick, so let me just close this and then rerun the model and then slow down the speed. So you can see actually the animation of the entity, actually part. So part enter the drill press and then leave the system, right? And then animation show you the machines processing the part, right? Drill press processing the part, right? If you at the end of simulation, when you click the result, and definitely you can see the simulation report, which is automatically generated by the Arena. So Arena internally use SAP Crystal report. So yeah, it takes time sometimes to generate the report because internally it handles the internally it has a lot of data, so that's why it takes time to generate the report. And here you can see the category overview, number out in average. Yeah, we have 5 entities, and if you click each category, and then you can see the entire data. So there is a value added time, non-value added time, wait time, transport time. Okay, then total time. So total time means time in system. Okay, so this is in average. The entities actually spend their time about 6.4 minutes, right? And then number in 7, number out 5, right? And then work in process in average 1.7 entities, right? So and then in processing you can also see the statistics, okay, performance of the process. And the center value added time is service time, okay, so 3.4, and this time is exactly same as the time in the system of the entity, right? So because we only have one queue and one server, that's why. Yes, it's the waiting time in the queue is 3 minutes. So if you add this value to this, and then you will get the total time, right? Yeah, and so on. And then yeah, there is a specific information for the queue, so you can also consider the queue as well. Anyway, so that's a report of this simulation model. Let me go back to the slide and then to explain, I will explain about the arena, especially basic functions of the arena. And then here is a snapshot of the simulation model, and then it has a toolbar, and this side is toolbar. Okay, so you can use this toolbar to conduct the simulation study actually, or develop the simulation model. And project bar having the multiple modules used in the simulation, especially arena. And we have a flowchart view. I already told you that actually introduced this one as a main window, but yes, but you can also use a flowchart view. So this is the model window, so you can actually put the modules in the project bar and to here. Okay, and then we have a spreadsheet view, which is a data module. So basically it has all the input data actually for each module. So if you click the one of the module in the model window, and then basically you can see the properties. And we have status bar, so when you run the simulation model, you can see the actual simulation runtime here. And let me introduce the several actually basic modules using the arena. I already mentioned about the create module, right? Generating the entity and part, right? So it has a name, which is just label, and then you can specify entity type, interval time, and first generation of the entity, and entity per live, and so on. I already mentioned this one in detail previously, so that's why I just briefly mentioned this. Also, there is a process flowchart module or process module, and in Arena, and so I already mentioned about this one, right? We have a drill center using the drill press as a resource, right? And they spend this amount of time, right? So, and then we have dispose module, which will update the tally statistics, right? Whenever entity passes this dispose model, and then Arena will remove the specified entity and then update tally statistic. Okay, so that's why you have to have dispose module in your model. And data module. So in data module, actually you cannot see any physical thing in your simulation model, but in data module you can specify the properties of the entity if you use the entity data module. Okay, and you can actually set the different types of entity in the simulation model. And then also we have resource data module, and you can specify the type of resources actually using this module. And in the previous model 3-1, actually we use what? We use drill press, right, as a resource, right? So you have to specify the resource, actually drill press, over in this data module. Also, we have Q data module. You don't have to specify the Q by yourself if you use the process module. However, if you want to use a logical queue or other queue, and then basically you can utilize this Q data module. You can specify the queue in this module. And there is a learning tool, simulation learning tool. One is the go button in the toolbar. Actually, you can find this button in toolbar. And then also we have a step button to debug, and also fast forward button to turn off the animation. Also, you have pause and the escape button. Okay. Also, we have sidebar to adjust the animation speed. Okay. Previously, I already used the sidebar, right, to slow down the simulation model. Yes, okay, and then simulation report, I already mentioned this part. And then yes, if you click yes at the end of the simulation, and then you can see this simulation report. And definitely you can generate the PDF file using this one. And then major types of the output in the report, it has a tally statistics, okay, and time persistent statistics, such as queue length and working process. And also you have a counter. Okay, so in order to especially in counter, actually we use this for what? Counting entities, passing counting the number of entities passing through the point in the model. So that's why you can use a counter using the different module such as a record, but I will explain that one in future. And also we have animation. So you can actually add the animation by using animation menu, especially you can visualize idle or busy the image, actually the VG animation, using two different images. So you need to set the image for the idle state of the resource and then busy state for resource. Okay, so based on these two images, actually Arena will just change the images over the simulation run, which will be described as a something like animation. Okay, and we have also in model 3-1 there were two plots, right? One is two dynamic plots. One was showing the number of entity in the queue, right? NQ function. We use the NQ function to show the number of entity in the queue. So this is NQ is a built-in function, and then if you type the NQ with the queue name, and then basically you can get the number of entity in this specified queue. Okay. And R also same thing. It's a built-in function. If you type the resource name such as drill press, and then you can see the number of BG resources. Got it? Right, so far I explained the major buttons and modules and also the other functions using this arena. And also based on my tutorial video, and I guess you can also successfully develop the model 3-1, and feel free to let me know if you have any questions in future. Okay, thank you.